Hello Megabytes teachers, and welcome to our video series introducing the concepts of GIS and how to use ArcGIS Online to explore data related to your mosquito research. We'll start at the very beginning. Let's break this acronym, GIS, out to its component parts. G is for geographic. Everything happens somewhere. I is for information. This is the data we are interested in. And S is for system. How do we store, view, and analyze our data? Really, GIS is not that different from most other forms of data science. We use GIS to explore data and look for trends in that data. It just so happens that we specialize in data that has a geographic component. Let's explore a hypothetical data set we might see, and then we'll talk about how we make it geographic. Most of the data we use is in the form of a spreadsheet or table. You probably use this type of data all the time in Microsoft Excel or Google Sheets for keeping up with grades or attendance. A table consists of just a few parts. Across the top of the table, we have a list of column names. All the data in a single column is the same type of data. For instance, in a gradebook example, each column would be a single assignment like Homework 1 or Quiz 2. Down the side of the table are rows. Each row is a single record in the data set. For instance, in a gradebook example, each row would be all the grades belonging to a single student. Let's explore how we can make this table geographic. If we add a column for each student's home address, then we can use a website like Google Maps to see where that student lives. We could actually mark all the home addresses of our students using this technique. Once we know where students live, what sorts of questions could we ask with that data? Let's continue to use a gradebook as an example. Let's say you explore notes for each class and find that 4 students are consistently sleeping during your class. What is it about those 4 that causes them to sleep so much? You use Google Maps and see that all 4 students live on the far edge of the county. A quick check of the school bus routes shows that their school bus arrives really early in the morning. Based on your data, you suspect that maybe the students aren't getting enough sleep because of how early they get up to catch the bus, or possibly they are rushed every morning and skip breakfast so they don't have a lot of energy to make it through until lunch. We could even use GIS to find alternate bus routes. To me, this simple example demonstrates the real power of GIS, which is using data to answer questions and solve problems that have a geographic component. Let's look at a different example. Another powerful component of GIS is the ability to combine multiple layers of information to help solve more complex questions. Let's pretend this drawing represents downtown Knoxville, the Tennessee River, and South Knoxville. You've been hired as a consultant for Scruffy City Coffee to find the ideal location for a new coffee shop. Scruffy City Coffee has a customer loyalty program where customers can earn a free cup of coffee. As part of that program, the customers provide you with their address to receive additional coupons. From your data, you see that most of your customers live in South Knoxville and probably commute into downtown Knoxville every morning for work. Next, you explore streets layers because you know that most people buy coffee in the morning, so you want the new coffee shop to be on the right side of the street as your customers drive into work. You know that you can't just put a coffee shop anywhere. It has to go into an existing parcel of land. So you add a parcel layer and filter it to include only those parcels on the right side of the street. You notice that there's still a lot of options, but some of those parcels are in residential neighborhoods and you can only build your coffee shop in a parcel that is zoned commercial. So next you add a layer of data that shows how each parcel of land is zoned and filter it out to only show commercial properties that are on the right side of the street. Finally, you know that the steeper a piece of land is, the more expensive it is to build on. So you want relatively flat parcels. So the last step of your data analysis is to add an elevation model and filter out those parcels that meet all of your criteria, on the right side of the street, in an existing parcel zone commercial, and below a certain slope. So what kinds of data go into the spreadsheets for each of these layers? Well, your customer data has columns like name, address, and birth date. Those are all examples of textual data, commonly called qualitative data. Your customer spreadsheet might have another column for how much money that customer spent in your store. That column is numerical data. Numerical data is commonly called quantitative data. Your streets data also has a lot of columns. Some are qualitative, like street name and surface type. Other columns are quantitative, like the speed limit. Parcels also has a lot of columns. The address of the parcel, the owner of the parcel, and the zone of the parcel are all examples of qualitative data we might see in this table. The table may also contain columns for the assessed tax value, the square footage of the parcel, and how many feet of street frontage the parcel has. Those are all examples of quantitative data. I can do this all day, but I'll stop for now. I think that covers enough of the basics that we can start exploring data relevant to your Megabytes project. Thanks for following along.